Today we're looking at notes 8-3 continued. So we're still finding the zeros, stating the multiplicity when greater than 1, and drawing a rough sketch. It's just that now the polynomials are given to you in standard form instead of pre-factored form. So unfortunately on these you will have to factor first and then find the zeros. So on this first polynomial here we're finding zeros, so of course we want to plug in 0 where we see y, if it's not already. Okay, and then look first always for a GCF and lead negative. So here we have a GCF of x, so I'm going to factor that out, x squared plus 3x plus 2. Okay, and then we luck out because the a value here inside the parentheses is 1, so we won't have to group, okay? We will just be looking for numbers that multiply to 2 but add to 3. So numbers that multiply to 2 but add to 3 are obviously going to be 2 and 1. Multiplies to 2 but adds to 3. So x plus 2, x plus 1. Okay, now that we've got our polynomial in factored form, we set each factor equal to 0 and solve. Okay, but no work really needed for that. Here we know that this is going to give us a root of x equals 0. Here we know that's going to give us a root of x equals negative 2. And here we're going to have a root at x equals negative 1. Okay, then for your sketch, all right, you know you have roots at 0, negative 2, and negative 1. 0, negative 1, and negative 2. They're all singles, no doubles or triples or anything like that. Since you have 3 roots, it's third degree. Okay, so arrows face in opposite direction. Lead coefficient's positive, so right arrow up, left arrow down. Okay, and cut, 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 because it's just linear type graphs because they're singles. Okay, next example, 0 in for y. My GCF, I don't have a lead negative, is x squared. So I'll factor out x squared from all terms, so x squared minus 2x minus 15. Again, we look out the a value in the parentheses is 1. So we're looking for numbers that multiply to negative 15 but add to negative 2. Okay, so that would be 5 and 3, but 5 has to be negative. Okay, so 0 equals x squared, x minus 5, x plus 3, okay, which gives us our roots. So our roots are x equals 0, but it's a double because of the x squared, okay, and x equals 5 is a single, and x equals negative 3 is also a single. So I will have a graph that cuts through, or I shouldn't say cuts because not all of them cut, one of them is a bounce, that goes through the x-axis at 1, 2, 3, negative 3, 0, and 1, 2, 3, 4, 5. Okay, we have 4 roots, so it's including multiplicity, so fourth degree. Both arrows will face up, lead coefficient is positive. Remember, 0's your bounce, so you'll cut through here, you'll bounce at 0, and then you'll cut through here. Okay, both arrows face up as they should. Alrighty, next example. We've already got 0 in for y, that was nice. Okay, so 0 equals, GCF here is 2x, oops. So factoring out 2x from every single term, I get x squared minus 7x plus 10. Okay, again, that a value is 1. Woohoo, we're lucking out, aren't we? Numbers that multiply to 10 but add to negative 7. So that's going to be 5 and 2, but they're both negative. Okay, because a negative times a negative is a positive, and then you add them together, it equals negative 7. So you'd have 0 equals 2x, x minus 2, x minus 5. Okay, so my roots are going to be x equals 0 because the 2x, x equals 2, and x equals 5 because no doubles or triples or anything like that. So let's see, we've got 0, 2, 3, 4, 5. Okay, so this is third degree, and that means arrows in opposite directions. Lead coefficient's positive, so the right arrow's up. So it'll go up, it'll cut through, and then back down. So there's our graph. All right, next to last example here, number 4. So we don't have a GCF, but we do have a lead negative. I'm lying. We have a lead negative and a GCF of x. So lead negative, GCF of x. Okay, so this gives us x squared plus 2x plus 1 equals 0. Okay, and then again, yay, we luck out that lead coefficient in front here is positive 1. So we're looking for numbers that multiply to 1 and add to 2. So numbers that multiply to 1 and add to 2 are 1 and 1. So this is negative x, and then x plus 1 equals 0. So we've got a root of x equals 0, because that one there, and then we've got a root of x equals negative 1, and that is a double, because we've got x plus 1 twice. Okay, you could even write this as x plus 1 squared, okay, since you had 2 of those, so that's why it's a double. Okay, so coming over here for my graph, I've got x-intercepts at -1 and 0. Okay, -1's a double. This is third degree, because 1, 2 roots here, 1 here, so 3 total. Lead coefficient is negative, so my right arrow goes down and my left arrow goes up. -1 is my double, so -1 is where my bounce is. Okay, so bounce there, cut there. All right, last example. You probably guessed what's going to go on that last example. Okay, all this time we have had the beauty of factoring out a lead negative and or a GCF. In this case, we have neither. We have no lead negative, no GCF, and unfortunately, here my lead coefficient is not 1. So I need to remind you, my A value is not 1, what do I do? Okay, so you still make the same t-chart, but you've been doing this all along, you just forgot. Here on these other problems where A was 1, you take numbers that multiply to 2 and add to 3. Well, you're supposed to multiply this times this number, but what has been here all along? It's been 1. So every single time when you have 1 here, this times this is just this. So here we need to make sure, since that A value is not 1, that we're actually multiplying this times this. And in this case, since that's not 1, we would have 2 times -2, which equals -4. Okay, but it still adds to that middle number. So again, you've been doing that all along. It's just that all along you've only had a 1 here. And 1 times that number will always just be that number. Okay, so we're looking for numbers that multiply to -4 but add to -3. Okay, and so that's going to be 4 and 1, but the 4 is negative. Okay, and so here I have to group because I have that A value, not 1. So 2x squared and -2, those first and last get dragged down. These two go in between with an x attached. So -4x plus 1x, or just plus x. And then we group. So first two terms, what do they have in common? 2x. What does that leave us with? X minus 2. Last two terms, they have nothing in common but 1. So you factor out a 1, which leaves you with x minus 2. Okay, which is great because then you look at this set and you look at this set and they have in common x minus 2. So factor out x minus 2 from this set, you get 2x. Factor out x minus 2 from this set, you get plus 1. And don't forget your equals 0 at the end. Okay, set this factor equal to 0, you get a root of x equals 2. Set this factor equal to 0 and solve, and you get a root of negative 1/2. Okay, 2x plus 1 equals 0. You subtract 1 each side, and then you divide by 2. Okay, so we have only 2 roots, and that makes perfect sense. All along this has made perfect sense because your degree should tell you how many roots, and second degree, so I should have 2 roots, and I do. So second degree, that means even degree, arrows face in the same direction. Okay, I have a root at 2, a root at negative 1/2. Okay, arrows face in the same direction. Lead coefficient is positive, so they both face up. All right, so here, here. You already knew that. It should look quadratic because it's x squared. Okay,